All right, you're going to want your calculators for this, so get those handy if you don't have it. Section 5, we're going to get into angles of elevation and depression. This is just going to take our SOHCAHTOA one step further than what we did the other day. So on that paper in your packet, let's first draw a picture of what angle of elevation, angle of depression look like. An angle of elevation is going to come from a horizontal line. And you have to have that in order to have an angle of elevation or depression. From that horizontal line, you're going to have an angle that goes up, or a line that's going up. This angle X would be an angle of elevation. You have a horizontal line with a line going up. And the easy way to remember that, elevation, if you elevate something, you're lifting it up. So from your horizontal line, you have a line that goes up. Angle of depression is going to do the opposite. If you depress something, you put it down. So from a horizontal line, an angle of depression is going to go down. Y would be an angle of depression. That's really the only new thing with section 5. And then instead of just giving us the picture, they're going to give us a word problem this time around. We have to come up with the picture ourselves and then solve it. So we got a few examples here. We'll start with this first one. It says we have a boy flying a kite. He lets out 300 feet of string. The angle of elevation from the ground to the kite is 38 degrees. And assuming that the string is straight, how high above the ground is the kite? So let's put our ground down here. We got this kid. He's got his kite flying up here. And now we can start to put in the parts. It says that the kite lets out the boy lets out 300 feet of string on the kite. Here's the string for your kite. This is going to be 300 feet. And it says the angle of elevation from the ground to the kite is 38 degrees. Well, here's your ground, and then here's the kite coming up like this. So you do have an angle of elevation. You got your horizontal line with a line going up. That makes this the angle of elevation, which is going to be 38 degrees. And on this one, they're asking us how high above the ground is the kite. Well, here's the kite, here's the ground. So if we close this off, what we're going to do is form a right triangle. And this distance from the height to the ground is what we're looking for. We'll call that X. Then once you have your picture, now you're right back to doing SOHCAHTOA. From this angle, the 38-degree angle, the X is the opposite side, the 300 is your hypotenuse. If you go back to SOHCAHTOA, which one uses hypotenuse and opposite? Sine. So we're going to do our abbreviation for sine. Behind the abbreviation for sine goes the angle, which is 38 degrees. And then our fraction for sine is going to be opposite over hypotenuse. The opposite side is X. The hypotenuse is 300. And just like we've been doing all the last couple weeks here, if you put this over 1, that makes it a proportion. Cross multiply, we're going to have 300 times the sine of 38. And then 1 times X is going to be X. And now you can go to your calculator. On the calculator, you put it in just like it looks. 300 times the sine of 38. And that's going to be about 184.7. They don't tell us what to round to. So you can, if you want to round off to 185, that would be fine. On the test, you'll just have to watch for directions as to what they want you to round it to. All right, there's your first one. Now let's do another one. Second one here, we got electronic instruments on the treasure hunting ship detect a large object on the seafloor. The angle of depression is 29 degrees, and the instruments indicate that the direct line distance between the ship and the object is about 1,400 feet. Wants to know how far below the surface of the water is the object. So let's draw a picture of this. We've got our water up here, and we have a ship up on the water. And we have some stuff on the sea floor. Here's the floor of the sea. We've got some object down here, whatever it might be. And then from this treasure hunting ship, they can send out, their instruments indicate the direct line distance between the ship and the object is 1,400 feet. If you drew a direct line between the ship and the debris on the ground here, that would be this line right here. That's going to be 1,400 feet. And it says the angle of depression is 29 degrees. Now, we have to pick which one's the angle of depression. You've got the water surface up here and a line going down. You've got the bed of the sea with a line going up. Which of these two angles is going to be the angle of depression? The one on the bottom or the one on the top?
The top. The top. The top one.
The top one's going to be. Just the bottom one, you've got a horizontal line and a line going up. That's an angle of elevation right there. Here, you've got the surface of the water. From that horizontal line, you have a line going down. This is going to be your angle of depression. This one's 29 degrees. Remember, with an angle of depression, you have to have that horizontal line with a line going down. And then over here on the right, we can close this off to make our right triangle. And what are they asking us to find here? They want to know how far below the surface of the water is the object. Here's the surface of the water. Here's the object under the water. This distance right here is X. All right, any questions with the picture first before we just solve this one? Okay, once you're to here, now it's just a matter of doing SOHCAHTOA. From the 29-degree angle, the 1,400 is your hypotenuse. The X is the opposite side. Opposite and hypotenuse will once again be sine. The angle goes behind the abbreviation for the sine. On the right, your fraction for sine is opposite over hypotenuse. Opposite side is X. Hypotenuse is 1,400. Put this over 1. You can do your cross multiplying on the proportion. 1,400 times the sine of 29. 1 times X is X. And then we're back to the calculator. And let's get this where we can see it. On the calculator, we're going to put in 1,400 times the sine of 29. That's about 678.7. Any questions with those first couple? All right, let's try the last one here. We have an escalator from the ground floor to the second floor of a department store. It's 110 feet long and it rises 32 feet vertically. Wants to know the angle of elevation the escalator makes with the ground. So for our picture here, here's the ground floor, here's the second floor. We've got an escalator that takes us from the ground floor up to the second floor. So this thing here, this is going to be our escalator. Then we can start putting in the parts of the problem here. It tells us the escalator is 110 feet long. So this length here is 110 feet. And the escalator rises 32 feet vertically. Vertical is up and down. So that means the height of that escalator is going to be 32 feet. Well, the height is going to go from the second floor down to the first floor. There's your vertical distance. That's going to be 32 feet. And this time around, it wants to find the angle of elevation the escalator makes with the ground. Well, here's the ground. Here's the escalator. That is an angle of elevation right there. You've got the horizontal line with the line going up. This is your angle of elevation. They want to know what that is, so we'll call it X. And now we're set. From here, the X, we have the 110 is your hypotenuse. The 32 is the opposite side. Once again, opposite hypotenuse is going to be sine. Now, it just so happens that all three of these we use sine. It's not going to be sine every single time when you do angles of elevation and depression. That just happens to be the case this time around. So you'll use sine, sometimes you'll use cosine, sometimes you'll use tangent. All right, back to this one. After the sine goes the angle, which is X. On the right-hand side, for the fraction for your sine is opposite over hypotenuse. That's 32 over 110. So the sine of some angle is going to be 32 over 110. To find out what the angle is, we'll do the inverse sine of 32 over 110. And back to the calculator for this. The inverse sign, 32 divided by 110. That's going to be about 16.9. 16.9, 17 if you round it to the nearest degree, or nearest degree would work also.
Bless you.
Once again, when you get to the test or the quiz, you just got to watch the directions as to what they want you to round to. This time around, they don't tell you what they want you to round to. So you can kind of decide. All right, any questions with those three? Okay, now one more, one from the assignment that I want to start with you. You can turn it over to the next page and go down to number 7. We're going to draw the picture for this one, and then I'm going to let you solve it on your own, but I want you to get the picture set up first. It says a person standing 35 feet from a flagpole can see the top of the pole at a 35-degree angle of elevation. The person's eye level is 5 feet from the ground, wants to know the height of the flagpole. So I'm going to put the flagpole over here. We'll make it a U.S. flag. There's our flagpole. And then we got a person standing 35 feet from the flagpole. Let's put them over here. They're 35 feet away from the flagpole. This distance would be 35 feet. And it says they're looking up, they can see the top of the flagpole at a 35-degree angle of elevation. So when they look up, they see the top of the flagpole. That comes down to their eyes. Now, here's the one new thing on this one. The person's eye level is 5 feet from the ground. So this distance right here is 5 feet. And what that's going to do to my picture is when I go to close this right triangle off up here, I'm going to come out from this eye level and do that. That gives me a right triangle. And now what we're going to do is kind of transfer some things along. So the bottom from the flagpole to the person is 35 feet. That's going to be this exact same distance at the bottom of the triangle. And then they want us to find the height of the flagpole. The entire height of the flagpole is this whole length here. Now what we're going to do is carry this across. This distance right here is 5 feet, which is going to make this distance here 5 feet. So our triangle is taking all of the flagpole except for that bottom 5 feet. So when we go to find the length of the flagpole, this X right here is going to represent from the top of the flagpole 5 feet above the ground. This is not the entire length of the flagpole, it's just from the top to 5 feet above the ground. So when we actually do find X, our answer, we're going to have to add 5 feet to it to get the length of the entire flagpole, because that X is not your entire flagpole. Now, the one thing we're missing on here is the angle of elevation. That's 35 degrees. Angle of elevation comes from a horizontal line with the line going up. There's your 35-degree angle. So when you go to solve this, if you want, you can kind of cover up this stuff on the bottom. And then you got a 35-degree angle. You have the opposite side is X. You have the adjacent side is 35, or yeah, 35. Are you going to use sine, cosine, or tangent on this one? This one's going to be tangent, because you've got opposite and adjacent. Okay, and then remember, once you solve for X, that's just the top part of the flagpole. You still have to add on that 5 feet on the bottom to get the entire length of the flagpole. I'm going to leave it to you to finish that off. Are there any questions before we get some time to work on that? Okay, now the hardest part of this whole deal is drawing the pictures. So if you're struggling with the pictures, just come back. I can help you with that. The answers for these are on Google Classroom, and they all include a picture that goes with it, so that can help you out also if you want to look at those. You should have time to finish it here today in class, so when you do, bring it back and we'll put it in the grade book today. And that's it. You got the rest of the time to work on it.